Hi, welcome to the stream. So, I just finished a 2 hour long stream of Human Resource Machine where we went through several of the different problems. Human Resource Machine is a game where the central gameplay mechanic is basically programming akin to, very similar to assembly language. Now, my stream totally messed up. The settings were wrong. Um, Basically the video just couldn't keep up with where I was. The audio was perfect. It was perfectly in sync. It was right along where I was. But the video was like a minute behind, totally messed up. So I apologize about that. What I'm going to do for now is actually give you just a quick rundown of basically what happened, basically what I did in the game. So we are going to launch Human Resource Machine, and we're going to show basically what's going on. And so get that started. We're going to review basically the 4 puzzles that we did. So we did countdown, multiplication workshop, zero terminated sum, and Fibonacci visitor. So going real quick here in the countdown, this is basically a countdown or count up. So this first number here, this 7, I'll go 7, 6, 5, 4, 3, 2, 1, 0. This -8, we'll go -8, -7, 6, 5, 4, 3, 2, -1, 0. And if it's a 0, we're just going to straight up put out 0. So this took quite a bit of time. And going through, this is where we ended up. Now, what this is, and what we did here, was in order to get both the efficiency and the size, both the size and the speed metrics. First I had the size, and it was very straightforward. But in the end, in order to get the speed metric, we had to do some extra shenanigans here. So we'll just run this as is, and so what we should see is our size is going to be a little bit above, but we did get it, and then our speed should be right on. So it's going to take the 7, put it out, put it down to 6, put it out, down to 5, put it out. I'm going to speed this up just a little bit here. We can obviously see that this is working. The point down here for this extra bit is to basically eliminate an extra step where it goes beyond 0 and then just throws away the results. And so those extra little pieces actually made it go just a smidgen faster in fewer steps. So we can see that we took 14 commands, but our best used 10. And we can see that this took an average of 81 steps. So we did pretty good. So our next one is multiplication workshop. Now, we didn't get either of the bonus challenges here for this, but this was far more difficult. And so basically what we're doing is for a pair of numbers, we are going to multiply them and then outbox the result. We also gain the ability to put labels on our numbers here. So I actually labeled these similar to what I would do variables. So there's a count that I'm keeping count of the number of times that I'm doing something, and then there's sort of an accumulator. And this is the running total essentially. And then they give us a 0 right here. And so this actually allows us to sort of reset very easily. And really where it comes in is that we need to reset the accumulator to start over. So what we're doing here is we are grabbing sort of the first number, so as far as multiplication goes, this would be, in the 2 times 3, we're going to store the 2 right here, and then we're going to turn around and get the second number. So we've got 2, we're going to stick it right here. We're going to stick 3 in the count. And if count is 0, we're just going to jump down here and just outbox it. So we're done. If count is 0, we're going to just be done. Otherwise, we're going to copy to count, and then we're going to pick up back up at 0. And if that's 0, we're going to go out. So I'm going to go ahead and label this, and we'll just say X. So if X is 0, we're going to copy that out. So this is sort of an attempt between these two jump if zeros. Don't bother multiplying. Just send the 0 out and be done. Now, obviously, past those point is going to be the meat of what we're doing. And we've got 16 commands here. But basically, what we're going to do is we're going to copy wherever progress we had made into the accumulator, and then we are going to bump count down 1. So if this was 2 times 3, we're going to put 2 down here in the accumulator, and then count that 3 back down to 2. If that's 0, we're done. Like our count, when our count hits 0, we are done. Otherwise, we're going to copy from X and add it to the accumulator. And then we go back to check. And so we add it to the accumulator, store it back in the accumulator, just like we did up here. Bump our count, jump of 0. So let's go ahead and step through this. Put the 2 down, put the 3 in count. Neither of those are 0, so we're going to put the 2 in the accumulator, subtract. All right. So what we've got here is 6. That's 0. So we're going to put the 6 in the outbox. So we don't have, if I go ahead and pause this for a sec, or start this over, there's no multiply function here. Now, normally in programming, all I would do is just multiply it. There's no multiplication here. So that's why we're doing this the way that we're doing it. So I'm going to go ahead and fast forward this. So our first result should be 10. Second result should be 35. The 1 and 0. So the next should be 0. Next should be 0. All right. So we can see we're getting our results out. Now that was a lot. Now obviously we didn't quite make the commands. We got 16. We're just 1. We're 1 command off. And then steps-wise, stepping through it, we're 9 off. So, like, we're really close. We are really close to this right here. We could probably... Can we get this? Is there anything else? I really don't think we've got anything that could really do it. Like, I think if we took out like the jump of 0, like this first jump of 0, I think we could get the command, the size. So we would get that size down to 15, and we're going to get that this time. Oh. Uh-oh, that's a problem. We ended up in an infinite loop there. Okay, need to go back. Which one was that? Okay. No, I need that one. It's the other one I don't need. that right? I don't know. I am programming way too late at night, and that's the problem. Ah, okay. So you can see where we looped over and over and over again when X was 0. So not efficient at all speed-wise. But we got less commands. So I definitely would not want to leave that in. We went way up to 142. So we need that. Now I wonder... Hmm. So we could probably do a few things here. So if we copy to X and copy to the accumulator immediately. So this jump is going back up here. What if we copy to the accumulator here? So that's going to be more commands. But I think we cut out a little bit. Hey, we actually went up. That's not right. All right. Huh. So if it's 0, we're going to copy from the accumulator outbox. If it's still positive, copy from X, add to the accumulator, copy to the accumulator. Jump. Hmm. Well, we could shortcut this a little bit by saying that if this is 0, we're going to go down here to some other piece where we inbox. So we throw that away. We copy from 0. We outbox it. So we don't have to do anything extra here. So the other thing I was thinking of is if we flip-flop these. So count. Let's see. Count is actually the first one we get. And then we inbox. Jump if 0. Copy to X, copy to the accumulator. We can get rid of this copy. We can get rid of this jump if 0. Immediately bump count. Alright, let's try that. So still working the same way it did. But we're using the second number instead of the first is all. Oh, I missed a jump. Alright. So at this point, we jump back to the beginning. Alright. So anyway, this was the solution we got. And it just needs a little bit more optimization. We're doing pretty good. I'm feeling good about this one. We're still at more commands. Oh, 120. We're more steps and not less. Even though we are immediately inbox, copy from 0, outbox. What if instead we just outbox what we've got, inbox, and then inbox? Okay, that'll be good. That's good. Alright, so otherwise we copy it to count. We inbox again. If that's 0, we outbox. Jump back to the beginning. Alright. Otherwise, we copy to X, copy to the accumulator, bump it. If it's 0, copy from the accumulator, go out, jump back to the beginning. Otherwise, copy from X, add to the accumulator, copy to the accumulator, go back, copy. See, that feels like it should be faster, but it's not. I think a lot of the problem is we've got a lot of jumps. Yeah, I'm going to stop there. Uh, Next one we're going to review is the zero terminated sum. And so this had to do with these numbers come in. We're going to keep adding these numbers. We're going to sum them up until we hit a 0. Now, if we look back here, I was able to get this in steps, but again, not in... or I was able to get this in size, so I did this in as few commands as possible, and I actually beat the bar. But speed-wise, no. But anyway, this is a lot like if in a lot of lower level languages, like for example C++, if you've got a string, if you got a word like WORD, and you store that somewhere, like how does the computer know that that word ends after the D? It's just slapping WORD into a bunch of memory. And so without some way of telling it to stop, you'll just get WORD, question mark plus 9B12, whatever, as you go through. And so what do? Well, what we do is we use a 0, or it's often called a null terminator. So the memory in that spot after that WORD is just zeroed out. So in this case, we're doing something similar, except we're just going to add the numbers together. So we're going to add the 6, and we're going to add the 1, and then the 0 is here, so that means we're done. So 7 goes out. And so that's what it is. And again, I've given them some total. I put accumulator. We could put total. We could do running sum. There's all sorts of variable names that we could put in there. And that's really what this is. It's a variable. Kind of like in algebra. Like you solve for x. X is a variable. Here, I could name this x and y. And I guess we went through that one on the last one. But basically, I'm going to sort of skip ahead here. And just an initial skip. We're going to copy from base. And we're going to copy it to the accumulator. So this initializes our accumulator. And then we're going to get from the inbox. And if that's 0, we're going to copy from the accumulator and go out. So if this is 0, right off the bat, we're going to get base plus accumulator. We're going to get the base, which is the accumulator, and so 0 goes out. If, in this case, 6, 1, and 0, so we put 0 in, we add the 6 to it, we add the 1 to that to make 7. 0 is there, we're going to copy from the accumulator, put it out. And that's the part here. So if it's 0, we're going to copy from the accumulator, put it out. If it's not 0, we're going to add it to the accumulator and jump back up. So this is pretty small. It's 9. The bar to reach was 10 or less, and we hit 9. So that was really great. But we can see how we're going to initialize it to 0. Grab the 6, add it, store it. Grab the 1, add it, store it. Grab the 0, toss it. Hit the 7, put it out, reinitialize, back to 0. Alright, 9 over. So, if I were to optimize this anymore, it would probably be that initialized state. Something that says, after I get to the inbox, instead of somewhere where we've got, I don't know, something we figured out. No, I'm not even sure where I was going. This is a difficult one to optimize. I mean, we've got 9 commands. That's as small as we could possibly get. Like, how do we do this faster? The only way to do this faster is to eliminate a step. Really, the only possible step is that case where we're done, so we outbox it. Probably we go ahead and go straight to the inbox and put it straight in. But I'm not even sure that that's the right way to go. um, it would get rid of our copy from base. So we go straight to the inbox, and then maybe another jump of 0. And then we copy to the accumulator directly. Oh, that's probably it, huh? I wonder if how that'll do it for us. Ah, wait. What just happened? So we did the 7. It's the 0. Copy from the accumulator. Put it out. Go to the inbox. Jump if 0. It's not. Copy to the accumulator. Jump if 0. Or copy to the accumulator. Inbox. Jump if 0. Add to the accumulator. Copy to the accumulator. Inbox. Add to the accumulator. Copy to the accumulator. Inbox. Jump if 0. Oh, there we go. So if we're inboxing, and if it's 0, we're going to copy from the accumulator. That's not what we want if we just short-circuited. We want it there. I think we might have gotten this one. Hey, we still got 10. Hey, 68. I think I see a bug though. So our initial spot is here, jump of 0. Copy to the okay, so maybe not. No, that's good. That's good. I think we got this. We did it. All right. So we did that one. So the next one is the Fibonacci Visitor. So this is the much more difficult track. We're gonna. I am not gonna optimize this anymore. But this is far more complicated. So if you look at Fibonacci numbers, you may need to look at Wikipedia for this. But basically, you start with a 1, and you add it. You start with 2 ones, really. So if you got a 1, you get a 1. You're going to add those together and you get the next number. So 1 and 1 is 2. Then you're going to take that 2 and the one before it, add those together and get the next number. And so what I've got is X, Y, and latest. So you got 1, 1, 1, and 2. After you get that, you're going to copy one of the whatever's at Y. So it's going to be the 1. And you take the latest, which is the 2, stick it in Y. Then you do the next one. But basically, you're going to repeat that. And the point of this problem is, given the number, so on this case it's 5, I'm going to put that in base right down here. So we're going to keep going up until we hit 5 without going over. So if for example, this second one's 19, and if we look over here, we're going to go 1, 1, 2, 3, 5, 8, 13, 19. So we're going to stop there at the 13. And so that's what we've got. So we're going to put the inbox and copy this. So this is now our baseline. And then we're going to initiate it. So I've got a 0 and a 1. Add those. I'm going to get the 1. There we go. So at this point, basically when 5 minus the latest, or I think it's the other way around. Until those subtract and become positive, then I'm going to keep going. So you can see how I'm carrying over y to x, latest to y. And this was, I spent a lot of time on this trying to optimize for the second part of it. Or no, I got the second part of it. It was the first part. It was the commands. They want like 19 commands. And I've got like 30 on this. Something like that. So I could get it to go fast. I couldn't get it any smaller without it being ridiculous. But on the speed challenge, blew it away. The best was 125. So that is this problem. And we can kind of see, as it was a more complex problem, it was good to really label these variables. That really helped a lot. And then the other part was I also labeled this up here as my anchor point. So when I add x and y, and when I add y to my x, and I copy it over to latest, I'm then going to immediately subtract the base. And so if that's negative, I'm going to just keep going where I'm at. So right here, I'm going to copy from y to x and put that in the outbox. And then copy from latest to y. And then keep going. I go back to my anchor point. Now, if it's 0, I'm going to go put y in the outbox. And then I'm also going to put in, latest in the outbox. So, for example, up here, my first number is 5. Basically, it's going to get to that point in that check where 5 minus 5 is 0. So I need to put y, but I also need to go ahead and put 5. And then my other use case is basically if that subtraction is positive, I copy from y to the outbox and end. Because at that point, I am done. So that is probably... Oh. It's one way to actually make this faster. So this last one. Basically, I'm jumping, do the thing, and jump again. But I could pretty easily do my trick up here, moving that up to the beginning. Getting rid of this completely. And whatever is jumping down here, jump up here. And then... So that's actually going to make this faster. Okay, so here's an outbox, and then this should be a jump back to the beginning. But I could actually do that there and remove this outbox. So that makes that one less. So, okay, so that should, I believe, beat our very best. So I wasn't going to optimize this anymore. I was just going to let this be, but I actually found that pretty quick to get a bit closer. I believe that beats my best so far. So yeah, that is our best right there at 25 commands. So this is jumping back to the anchor point. This is jumping back up here. X, Y, out. Latest Y. Back to anchor. Y out, latest. So those are all very different. And I hate kind of doing some of this setup here. It feels like we could probably do some of that. But maybe not. So inbox, copy to base. So I think that's it. Anyway, it was kind of a shame that my stream didn't go too well. This part doesn't show me necessarily thinking the way through the problem, but it does show me the way through, like, optimizing it, and I'm walking through and explaining. So we're definitely getting further into the game, where the difficulty is ramping way up, the complexity is ramping way up. It is difficult in this because the way this is, and this is a lot of interesting, challenging problems, but yet at the same time, the way it is, we lose a lot of the power. So I usually program in something like JavaScript or TypeScript, or something like C#. So these are much higher level languages, where a lot is just written. So instead of saying like little jump statements, I can say, while this thing hasn't happened, keep going. So nice and easy to do that. But with jump statements, things are far more complex. And then there's also the fact that my conditions are much more limited. So if you look at the jump statements, I have a jump if 0, and a jump if negative. You don't have a jump if positive. I can add and I can subtract, but they've already asked me to multiply. They haven't given me a multiply operator. Like, just having to think about things in that way is far more challenging. And even if, and I sort of compare this to assembler. Assembler, you'd be able to multiply, you'd be able to divide, and if I remember correctly, I think you get it later in the game, but it was for that other puzzle ideal. And I've gone this whole way. I haven't once used little hints provided. I'm trying to avoid doing that. I think at some point, I think there's an achievement for actually going through and looking at all the hints, so I may do that at some point. But really, the point of this stream is just to give you an idea of kind of what this is, to walk through my mindset, to walk through, because these are pretty challenging problems, but also to be able to do this in a way that meets the challenges. And while on the first stream, we got every single one, we did it with relative ease. Obviously, we're getting to the point up here where this is far more difficult. This one alone, if I just click on it just to give a little preview of, I guess, what's probably in our next one. Obviously, we're going to be doing okay, so this is as if we were doing dividers, division, but they want the remainder. So, you know, these are getting far more difficult. And this branch here is meant to be the difficult track. Littlest number, this should be far easier. So for each 0 terminated string in the outbox, send to the in the inbox, send to the outbox only the smallest number you've seen in that string. You will never be given an empty string. That's important. Reset and repeat for each string. Okay, so just like we were doing before with the 0 terminated one, we're going to keep going through this inbox, and we're just going to keep track of the smallest one. So, you know, far simpler than the mod assignment. But, I mean, if we go and we look, you know, down here, like, That's... Did I do that? Like, just looking at this with fewer statements and the fact that we've only got 9 lines, like, we can see that we're ramping up quite a bit. Like, we've come a long way from the year 1 mailroom. So when we go and look at things like this zero terminated sum, and we turn that onto the other one, which is, the approach to that is basically going to keep a running minimum. Things are going to be very different. So I hope you've enjoyed this. I apologize, the first stream didn't work out. Took a long time, and then to find all that was wasted kind of hurt. But I hope to do quite a bit more of these streams. I'm gonna keep going somewhat on this game. There's some other games that I'm gonna try out, and if you've got any suggestions, feel free to leave them in the comments. If you've got any questions about programming, anything that I can cover, feel free to leave them. I plan on doing videos that are much more scripted, like lectures on this is what programming is, and this is how you program, this is how you learn to program, and then more advanced videos of some of the latest languages and frameworks and updates out, and even some live coding sessions where instead of playing a game, I'm coding through some sort of problem in an actual language, in an actual development environment. So subscribe, hit that like button, and we'll see you around.